Okay, hi guys. So in this lecture, we'll be continuing on seeing some more examples of E2 reaction. So let's continue. So we have some example like this, in which we have hydrogen atom attached here, atom attached here, and a Br here, and we pass it on with alcoholic KOH, heat it, or this can be actually the reagent can be NaNH2 also. It can be ETO minus. It can be this. Okay, so in all the cases this would be major product and this would be minor product. Okay, so how does this happen is obviously we would have something like this also. Okay, so this would be minor product. So do we actually see this type of product coming into the picture? So if you just if you just closely look into this, that um, we have something like this Br coming out, this CS3 coming out of the plane, this Br going inside the plane, and this H coming out of the plane. Then what we can get is something like a cis. Okay, cis alkene or cis butene. Hence these two products are possible and this is possible. Okay, but what happens, this is the alcoholic KOH. I hope you have noticed this. What happens if we use, this is the same product and we use aqueous KOH? What happens in this case? Then we would have SN2 reaction in which OH would act as a nucleophile and would attack on the backside of the carbon atom to remove Br. Okay, so it will be a inverted product, inversion in configuration, inversion in configuration. Okay, this acts as a nucleophile and here it acts as a base. Okay, so now the next question is how many halogens undergo E2 reaction when following compounds react with alcoholic KOH? How many halogens undergo E2 reaction when the following compounds undergo alcoholic KOH? Okay, so we have something like this. This is our first example. We have 6 chloro groups attached on the cyclohexane, each substituent to one of the to each carbon atom. So we react it with 3 mole of alcoholic KOH. What will happen is we will get something like this structure and Cl 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 on alternate carbon atoms. So how many halogens undergo E2 reaction? 3 in this case. What about this case? We have something like Cl here, Cl here, Cl here. So obviously this Cl, these two Cls cannot undergo, or rather can this Cl undergo double bond or undergo elimination? Yes, because here we can find a hydrogen at back going out of the inside the plane. Okay, so this can actually undergo elimination. What about this pair? This pair can also undergo elimination reaction. Any other pair? this cannot happen, because on alpha carbons on of this related to this carbon position, both the positions we have chlorine group attached. Similarly, we can say for this. Similarly, I can say for this, when I create the products, it would be something like this. Okay, and Cl would be attached here, and again this would be something like Cl. Oh, I'm sorry, Cl would be gone here. Okay, and Cl would be here. So in this case, answer would be 2. Okay, let's jump into next example. We have how many chlorine halogens can be replaced in this case. Going inside the plane, coming out of the plane. So for this I cannot have, for this again I cannot have, for this again I cannot have, because in the anti position both are coming out of the plane. For this, into the anti position means going below the plane, both are having Cl positions. For this, for anti position, it requires any hydrogen to coming out of the plane, but both the alpha carbon substituents are coming out of the plane. So for this, yes, we can have a hydrogen here which is going down the plane. Okay, so we can have something like we can form a double bond here. So now what happens is there is no other scope, so hence the answer would be 1. Okay, let's look at the fourth example. Here we have something like this. So what would be the answer for this case? The answer for this case would be 0. Why? Because for this case both are below the plane, no hydrogen is there. For this case both are above the plane. For this case both are below the plane. For this case both are above the plane. For this case both are below the plane. For this case both are above the plane. Hence the answer for this case would be 0. Okay, so let us now look at another example. So we have something like this, that we have and CH3 here. It undergoes alcoholic KOH to form product this. Okay, and then it will undergo NaNH2, okay, to form product something like, again NH2 will attack on this then this hydrogen, and bond formation and bond breaking will happen in a one step, and we'll have something like this. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more such examples, or let us we have some time, we can see in this lecture as is this lecture itself. So we have something like this. If it reacts with PCl5, it forms product A. Now this A product undergoes 3 moles of NaNH2 to form product B, and this product B actually undergoes CH3I to form product C. You have to identify A, B and C. So what happens is, when this undergoes PCl5, we would have something like Cl will occupy both the positions. So we would have, and how would the reaction take place? Reaction mechanism would be simple, that pH it would be taking its electron, reacting with P, Cl 2 3 4, and Cl minus would be released. Okay, this Cl minus would be attacking again on this carbon atom, and it would be forming something like it would have PHC CS3 ClO and PCl4. Again, this will form a double bond here. It will take its electron from carbon, and Cl will attack here. So we will have something like this as formed product. Okay, so this is the A compound. Now what happens next is this is reacted with 3 moles of NaNH2. Okay, so oh, I'm sorry, I just forgot to, this is not CH3, this is attached with CH3 here. Okay, so now what happens is these two Cls will be removed by 2 Na. So we will have something like CH, and the last remaining Na will again attack, last remaining NaNH2 will again attack to remove this H atom. So we would have something like C minus Na plus as our B product. This is B. Now this B product actually undergoes reaction with CH3I. So what happens is, again this actually attacks on this actually attacks on CH3I to form product something like this, plus NaI would be formed. Okay, so this is product number C. Okay, so with this we come to an end of this lecture. In the next lecture we will see some more examples on the same concepts. So till then, good luck and goodbye.